Sometimes we will encounter polynomials at this point that do not appear to be factorable. Let's see what those look like. First thing I would want to do is, again, to make a product sum table. Note that my product is the first coefficient times the constant, so 1 times 32, which equals 32. And the sum will be the coefficient of my center term, so -1. So I'm looking for two numbers that multiply to 32 and add to -1. Well, let's look through the factors of 32. We have 32 times 1, which multiply to 32, and if I add them, that's 33, which is not -1. If I looked at -32 times -1, that also multiplies to +32, but that adds to -33, which is not 1. I also have 16 times 2, which multiplies to 32, but that adds to 18, which is not -1. I could look at -16 times -2, which also multiplies to +32, but these add to -18, which is not -1. And I could look at 8 times 4, which is 32, but 8 plus 4 is 12, which is not -1. And if I look at -8 times -4, that also multiplies to -32, but that adds to -12, which is not -1. At this point, I have gone through all of my whole number factors, and none of them have a sum of -1, so we will say that this polynomial is prime. We're going to look at this polynomial and see if we can observe the same thing going on. I'll always start with a product sum table. My product is going to be the coefficient of my first term times the constant. So 1 times -9, which equals -9. The sum will be the coefficient of my middle term, so my sum will be +3. So I'm looking for two numbers that multiply to -9 and add to +3. Well, I could look at -9 times 1, which equals -9, but that adds to -8, which is not +3. I could look at 9 times -1, which multiplies to -9, but that adds to +8, which is not +3. And I could also look at -3 times 3, which multiplies to -9, but they add to 0, which is not +3. If I reverse the signs here, I'm still looking at the same two factors of +3 and -3, which multiply to -9 and add to 0. There are no other whole numbers or integers that multiply to -9 and add to +3, so this polynomial is also